Hello everyone and good morning. Today inshallah we will continue on the determinants and the relations where we stopped in the previous lecture yesterday. Hopefully today we will be able to finish this part. It's really very important, as I told you, just to go through it step by step and to link all the properties and the propositions together. First of all, I want you to remember the following statements. First, elementary row operations in determinants. There is a slight difference between the row operations in determinant and in matrices. In matrices, the three main row operations, we already know about them. Switching rows, multiplying row by a number, multiplying row by a number and adding it on another row, okay? It's not gonna change the value of a matrix. It's actually getting you an equivalent matrix to the original one. But in determinants, due to the properties of determinants, it will lead to slight differences. You will have to know the difference between them. Okay, the value of a determinant changes sign. This is really, very important. Changes sign. Once you switch the rows, we need to play with these row operations if we want to get echelon forms or reduce the echelon form for any reason. We will need this row operations if we want to evaluate determinants of higher degree than the third one. I will do an example with you today, okay, on these row operations. So just keep in mind, in determinants, once you switch the rows, once it will change the sign of the value of the determinant. But if you switch the rows twice, it will be positive, and so on. Okay, number two, multiply a row by a non-zero constant will lead to the value of the determinant, the original determinant, will be multiplied by this value, okay? That's a difference with these two row operations are different than the matrices. The third one is not gonna change anything, which is very funny. Multiplying the row by a multiple or by a constant and adding it on another row, it's not gonna change the value of a determinant, okay? So out of the three, there is two have an impact on the values of the determinants, but the third one, no, okay? Determinants of elementary matrices. First of all, I want you to remember, what's an elementary matrix? What's an elementary matrix? The elementary matrix is a unit matrix. You do one of the operations in it, and once you multiply this elementary matrix by any matrix, it will do the row operations. So they call it elementary matrices due to the three operations, which is switching rows, multiplying by a number, and so on, so on. Okay, so E, Ri, Rj is obtained by interchanging row I and row j, okay, in a unit matrix. Okay, E alpha Ri, it means you will multiply the Ri row, the row which order is I, okay? So second row is going to be R2, R1, R2, R3, and so on. If you multiply by alpha, the value of the determinant will equal to this value of alpha. If you add a multiple of another row to any row, it's not going to change the value of the elementary matrix. I mean the determinant of the elementary matrix. What's the value of a unit matrix? The determinant of a unit matrix. Any ideas? Omar, the determinant of the elementary matrix, 2 by 2. What's the value of the determinant? 1. 3 by 3? 1. 4 by 4? 1. Why? Because it's a diagonal matrix, all the elements are 1, so once we know from the previous lecture that any diagonal matrix, if you want to evaluate its determinants, it's really very simple. All you have to do is to multiply the elements on the principal. Okay, very good. Determinant of identity matrix is equal to 1. This is axiom number 4. Those propositions are really very important. He's stressing once more the value of a determinant. Once you switch the rows, it's a matrix. So it will not equal to positive 1, it will be negative 1. If you do a double switch on rows, it will regain again positive 1. If you multiply an elementary matrix by a certain number, say, let's multiply the second row by 2. If it was 3 by 3, it's going to be 1, 0, 0. Then the second row will be 0, 2, 0. The last row will be 0, 0, 1. And this will lead that the value of the determinant will equal to 2. Okay. The last one is multiplying whatever and adding on the rows, the value is equal to 1. Okay, recall that if E is an elementary matrix obtained by executing the row operations, blah, 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 the determinant of EA is equal to the determinant of E, which is 1. Or one of these operations, if you do it, times the determinant of the original matrix. تمام? Okay. The determinants satisfy the following properties. Those are really very important. And of course, you know most of them. The first one, the determinant of a triangular matrix. It's triangular matrices, diagonal matrix. They are the same. The value of the determinant will equal to the multiplication of the elements on the principal diagonal. So the determinant of a triangular matrix, either upper triangular or lower triangular, okay, is the product of the diagonal entries, multiplying the diagonal entries. This is number one. Number two, a matrix A is invertible if and only if determinant of A doesn't equal to 0. And for any matrix where its determinant doesn't equal to 0, we call it non-singular matrix, which is a condition to get the inverse, okay? So this is also something you have to hold in mind. Remark that if I want to get the determinant of matrix A times matrix B, it's gonna equal to the determinant of A times the determinant of B. This is really a very important property. I have to add this information. The determinant of A plus B, it doesn't equal to the determinant of A plus the determinant of B. This is the general definition. It may happen in certain cases, but in general, a determinant of addition of two matrices is not equal to the determinant of the first plus the determinant of the second. Okay? So it's really major to understand that determinant of A times B, it's equal to determinant of A times determinant of B. But the addition, no. Determinant of A plus B doesn't equal to determinant of A plus determinant of B. Okay? This is also a very nice remark. Determinant of A, it's equal to 1 over the determinant of A minus 1. It's equal to 1 on the determinant of A. So if I have a matrix, its determinant is 2, and it is invertible. So the determinant of the inverse matrix will be 1 over 2. If I have a matrix and its determinant is negative 5, so the inverse of this matrix is going to be negative 1 over 5. Okay? This is really important. Okay, once more, the determinant of A transpose is equal to the determinant of A. These remarks and the propositions is really very important. You have to keep them in mind. Okay? So, if I were in your shoe, I will have to review the propositions in matrices. I will have to review the propositions in the inverse. I have to review the propositions in transpose. I have to review the propositions of determinants. Because usually they are confusing. Okay? For these slight differences. Once more, details of evaluating the value of the determinants in case of a triangular matrix. This is how we can evaluate it, explained to you in this paragraph, but I would prefer to look at it like this. Let's look to this upper triangular matrix, a general upper triangular matrix. We already introduced in the previous lecture Laplace method. Do you know what's Laplace method for evaluating a determinant? To choose any row, don't forget that. To choose any row or any column. And to start element by element, taking the element, eliminating the row and the column, and evaluate the determinant of the smaller matrix, and then element by element. This is the Laplace method. Okay? Okay, just a quick reminder. If I want to use Laplace method to evaluate, we will do it more than once, but it's okay. Let me give you an example. If I have, let's say, a matrix which is 3, 2, 1, negative 1, 0, and 2, 3, 4, and 5. And I want to evaluate, using Laplace method, the value of this determinant assigned to this matrix. This is matrix A. Okay? Of course, I can do Sarah's rule. Okay? But I want to use Laplace method. So I will choose any row or any column. I will do it with the first row for this one. Okay? Let's remember the sign rule. The sign rule for the first row. What is it?
Minus, plus.
Positive, positive, negative, and positive. So I will start taking the first element, which is 3. The sign is positive. I will eliminate the row and column for this matrix. So I will have a smaller one, which is 0, 2, 4, and 5. Then I will put the negative sign for the second element, which is 2. Replace, eliminating the row and column. The remaining numbers are negative 1, 3, 2, and 5. Then plus 1 times, same way like eliminating row and column, and getting, it's called the cofactor. It's called the algebraic complement, which is those 4 numbers. Negative 1, 0, 3, and 4. Okay, if I want to, it's done. It's really very simple. I will multiply the elements of the principal diagonal minus the elements of the secondary diagonal, and it's done. Okay. Usually, when I try to expand, because I know that the result with the first row, second row, third row, first column, second column, third column, it will be the same. So I will choose in all times the row or the column with a huge number of zeros. So if we go with the plus with this upper triangular matrix, let's look at it. That's a matrix n by n. If I want to evaluate if I want to evaluate using Laplace, what's the best to use in order to evaluate the value of this determinant? The first column, yes, the same. So I would start with the element A11. Okay? Eliminating the row and column, I will have a smaller matrix. Okay? A smaller determinant by 1. And it's gonna equal to, of course I'm not gonna evaluate anything else. So if I want to do it here, let's remark it, I will do 2 elements for you. If I want to do it, then it's gonna equal to A11. Then eliminate the row and column. What are you going to have? A22, then A23, blah blah blah, till you reach A2 and n. Then there will be zeros here, am I right? Then the last one, it's gonna be A n minus 1, A n minus 1, because the dimension reduced. If I want to repeat it once more, I will go to the element, I will choose also the first row. Then I will use this number and eliminate the row and column. What's gonna be? A smaller one. So it will accumulate A11 times A22. Then the remaining matrix will be A33 and A33, A4. Then, and so on, up till you reach A3 to n minus 1, because we eliminated just one row. Same way like, those elements will be 0, and so on. Do you read what I'm saying? Do you understand me? لغاية لما تنتهي خالص. بص. This is the first complement. This is the first part. I will use the first column. So it's gonna be A11. Okay? And then I will eliminate, he used the row. I've used the first column, but you can use the rows also. If I used the last row, it's gonna be A n n, negative 1 to the power of n times n. Then I will get the determinant corresponding to A n by n, which means you will eliminate the last row and the last column. The remaining matrix will be also our triangular matrix. So I will use the last row also. So the last row will be A n n times A n minus 1, A n minus 1, times negative 1 to the power of n by n, which is whatever the value. Then it's going to be negative 1 to the power of n minus 1, times the determinant n minus 1, n minus 1. So I will reduce the degree once more, and so on. So by doing this, the determinant of this upper triangular matrix will equal to the multiplication of the elements on the principal diagonal. That's the proof of how to evaluate an upper triangular or lower triangular matrix. Okay? I will do it on an example once more to make your life easier, since the look in your eyes is not comforting. Let's say I have a matrix, 3, a determinant, 3 by 3, 3 double 0, 2, 4, 5, and negative 1, 0, and 2. That's an upper triangular determinant. Am I right? Okay, let's choose either the first column or the last column. It's up to you. I will use the first column. Let's say I will use the first column. So I will take 3, the sign is positive. Then I will eliminate the row and column. What's gonna be? 5, negative 1, 0, and 2. I will do it once more. So it's gonna be 3 times, I will use the first column. The first element is 5. Then I will eliminate the row and column. So I will have a determinant of a matrix 2, which means it's a 3 times 5 times 2. It is the multiple of the elements on the principal diagonal. I don't have to do it anymore. If I have an upper triangular matrix, directly, the value of the determinant is going to be 3 times 5 times 2. And this assigned with Laplace rule. Are you with me? If it was 4 by 4, it's going to be the same. 5 by 5 is going to be the same. Okay? This is how we prove it. Examples. Those are various examples. I will do it, although we can solve it on a 3 by 3 determinant very easily, either by Sarah's rule, or by Laplace rule, or by the following manipulation. Of course, what I'm going to show you right now, I'm not going to do it on a 3 by 3 mainly, but I will use it if I have 4 by 4 or 5 by 5. Let's start. Okay, please be careful. This is the matrix A, the determinant of matrix A, which is 1, 2, and 1. 1, 3, and the negative 1. Negative 2, 0, and 4. I will try to reduce, okay, the determinant using the properties of the row operations, ya Omar. But keeping in account the properties of the row operations and its effect on a determinant. So let's start. I need this determinant, leave what's written on the white on the screen, and let's do it together. I will need to reach an echelon form. Noor, how to get an echelon form? First step, I will need this number to be positive 1. It's going to be simpler on me to force the elements beneath it to be zeros. Okay. One of the rules that I will use, I will keep the first row as it is, which is 1, 1, and negative 2. Then I will add a multiple of the first row on the second row. How to force this number to be 0? Multiplying the first row negative 2 and add it on the second row. This operation doesn't change the value of the determinant. Do you remember the 3 operations once more? If I switch the rows, the sign will be negative.
Multiplication.
If I multiply by a number, the value of the determinant will be multiplied by this number. If I am adding a multiple of a row to another row, it's not going to change. So I will use negative 2 plus 2 is going to be
0.
Negative 2 plus 3 is going to be negative 2 times negative 2 is going to be 4 plus 0 it will be. The value of this determinant is exactly the value of that one with the change that I made in the second row. I will do it once more. Okay, I will multiply the first row negative 1 and add it on the last row. Negative 1 plus 1 is going to be negative 1 plus negative 1 is going to be negative 1 it's going to be 2 times 4 it's going to be 6. Also, there is no change in the value of the determinant.
معلش ممكن سؤال تاني؟
اتفضل.
رياضة؟ لا نعمل مسألة تانية.
هنشوف بس لما نخلص دي هنشوف ايه. ماشي؟ كمل.
واحنا كنا بنعمل في لاس اوبريشن بنعمل لاس لاين رو 1 minus رو 3
Row 1 minus row 3 it means multiplying the first row negative 1 and add it on the last row. Okay? ها زياد معايا؟
لا.
هعيدهم تاني.
يا ريت.
Okay. أنا عايز أعمل إيه؟ I want to evaluate the value of this determinant. Okay? I need to develop an upper triangular matrix. Why? Because if I have an upper triangular matrix, the value of the determinant will equal to the multiplication of the numbers on the principal diagonal. Am I right? Okay. I have 3 row operations. We already know them. If I switch the rows, the value of this determinant will equal to a negative sign of this determinant. Okay, so I will add negative. If I multiply this row by a number and leave it, so if I want to multiply the first row in 2, it will be 2, 2, negative 4, and the value of this determinant will be multiplied. This one, it will equal to 2 times this value, and so on. But if you add a multiple of a row to another row, it will be the same. So I'm using an advantage of this operation. I'm multiplying the first row in negative 2 and add it on the second row. Then I've multiplied the first row in negative 1 and add it on the last row. Once you do so, this determinant value is exactly like this one. We don't have to do anything. Okay? This is what I did. This is for this operation. I need also to make positive 1 equal to 0. ازاي اعمله يا زياد؟ I will multiply the first row in negative 1.
ماشي.
Then I will add element by element to the last row. Multiply. Negative 1 plus 1. Negative 1 plus negative 1 is negative times the negative 2. It's going to be positive 2. Plus a 4, it's going to be 6. Very good. I will continue.
اعمل نيجاتيف 2 بعد
Okay.
كده 0.
I need this number to whatever what it is. I need the number beneath it to be 0. How to do it once more?
عشان يبقى upper triangle.
Okay. Yes, عشان تبقى upper triangular matrix. Let's do it.
هنضرب فوق ب 2.
I will leave the first as it is. The second will be the same because it has positive 1. Positive 1 and 4. Then I will need to force this number to be 0. So what to do? I will multiply the second row in positive 2 and the added. Let's multiply. 2 times 0 is 0 plus 0. 2 plus negative 2. 2 times 4 plus 6.
14.
Voila, the value of this determinant will be the sum or the multiplication of the elements on the principal diagonal.
طب ما احنا
So the value is 14. Done.
ليه ما نخليش 14 1؟
ليه اعمل كده؟ حتى لو حبيت اعمل كده I will multiply the last row. Very good. I will multiply the last row by 1.
1 over 14.
صح؟ يبقى إذا the value of this matrix of this determinant will equal to, once you multiply by 1 over 14 the last row, the value of this determinant will be multiplied by the value that you are multiplying by. So I will have 1, 1, negative 2, 0, 1 and 4, 0, 0 and 1. Okay, it seems it's like taking 14 as a common. So it will be once more, so you multiply the 1 over 14, multiply by 14. So it's going to be the same. Multiplying the principal diagonal elements is going to be 1 times 1 times 1. Then you have the number in front of this determinant, which is 14. It will give you the same value.
ليه اصلا 14 لما انا هيجاوز كلها 1 البرنسبل؟
حبيبي ده upper triangle، انا مش محتاج ان انا اعملها reduced echelon form. لو انا عايزه reduced echelon form برضه تاني هتلف على بعضها وتطلع لك النمبرز بره. كل نمبر انت هتعمله وتعمل فيه مطلوب كده هيطلع لك بره الجدول. اوكي؟
اشمعنى ضربناها في تاني رو؟
لانك عايز التاني رو هو اللي يبقى تحتيه الرقم اللي تحتيه بكام؟
طيب
يساوي 0. I don't have to do this step.
يعني لا ماشي انا فاهم، بس لما كنا عايزين ان اخر رو نعمل نخلي
1
لا مش واحد،
قول.
اخر رو تحت خالص نخلي الرقم اللي تحت بتاع الشمال ده 0 صح؟ ضربنا في اللي فوق.
ده
لا الشمال.
الشمال اللي هو ده.
ضربنا في اللي فوق.
بص انا ببدا بالترتيب.
ماشي وانا عايز افهم.
باخد لا ما انا بفهمك اهو. انا ببدا بالترتيب ازاي؟ بجيب الاول this number to be a pivot.
ماشي.
I will use it to force all the elements beneath it to be zeros.
ماشي.
بس خلاص هو عمل غرضه.
اوكي.
خلاص ماليش دعوه بيه. هنزل على مين؟ السكند رو. البيفوت هو مين؟ 2 2.
ماشي.
هستخدم النمبر ده to force the elements beneath it to be zero. So I will multiply this second row and add. Remark that the zeros is not gonna change لأنك بتضرب في zeros. صح ولا إيه؟ تمام؟ أوكي. لا معلش. خليني أخلص المسألة وأنا بسألني.
معلش يا دكتور، الحته دي عملناها مالتبلاي لاست رو مالتبلاي 1 over 14.
خد 14 as a common. أسهل من multiply by 1 over 14. مش أنا أقدر أسحب common from any row or any column، إنما الديترميننت طبعا البروبابيلتيز بتاعته عشان تبقى أسهل عليك. take ال 14 as a common بره. بدل ما تعمل multiplication وتقسم وترجع تضرب تاني في المقلوب. خد ال 14 as a common. مش احنا المرة اللي فاتت in the previous lecture زياد in the previous lecture اتفقنا if I'm going to multiply a row by a number in a value of a determinant عشان to keep it as it is I will multiply this number in any one row or in any one column. Same way like taking a common. The common will come out from
عرفت منين؟
one row or one column. Okay? Step by step. The last step دي I don't have to do it. خلاص it's evaluated since you have an upper triangular matrix. زياد. خلاص خليك معايا. اوكي زي ما انت شايف انا جبت دول وعرفت ان ده 14 ما فيهوش مشكله. طيب الكل بقى بلا استثناء خليك معايا. مستر زياد انت معايا؟ طيب انت خدت بالك ان دي بقت ابر تريانجولار ماتريكس وان ضربت الاليمنتس
ضربنا في بعض جبنا
قشطه. افتي
تطلع بون.
عارف ايه؟
افتي
عارف ايه؟
اظبط دي.
اظبط دي ماشي.
ها قول لي بقى اعمل ايه؟ نعملها سوا ايه؟
دي واحدة تانية صح؟
اه
ما هنخلي بيفت 4
ها اخلي البيفت ايه؟
0
هو فين البيفت؟
الزيرو
element 1
1 0
نعمل
ماشي يبقى انا عايز انا ما بشتغلش كده انا عايز ابر تريانجولار ماتريكس يعني عايز هنا طالما في elements عايز ده ب 1 او باذر فاليو بس ال1 دايما اوكي انا عارف انك فاهم اوكي انا فاهم انك فاهم بس عشان بس افهم اوكي انا عايز بدل الزيرو ده يظهر ايه؟ مش هتعرف تعمله الا عن طريق انك تعمل سويتش لمين؟ للروز صح؟
ماشي
طيب يلا واحده واحده
يلا
حضرتك شايف كده انا عايزه يبقى بوزيتيف 1
اه
عشان لما يبقى بوزيتيف 1 I will use this pivot to force the elements beneath it to be zeros. اوكي رايك اعمل ايه؟ اشقلب اوكي يبقى اذا اول ستيب
ممكن اشقلب
بص بقى اول ستيب just a second
ماشي
اول step if I were in your shoe
طيب
I will replace the last row instead of the first row so it's gonna be negative 1
I switch accordingly to
1
ماشي
2 the second row will remain as it is 2 1 and 1 the last row will be 0 الناس اللي بتتكلم من فضل 0 3 4 once you make this switch يبقى الساين هنا هتبقى بالايه؟ negative this is rule number one of the rules
ماشي
okay I need to change the sign of the first row plenty of ideas I can multiply in negative so I will multiply outside the negative or I can take negative sign as a common it's gonna be easier on you take negative sign as a common it will come from one row so I will take it from the first row so taking the negative one as a common it's gonna be negative 1 which is this sign times the negative 1 from the first row so it's gonna come up to 1 negative 1 and the negative 2 are you with me؟ حلو معايا مستر محمد معايا حسين
ايوه معاك.
okay the second row I need this element to be كام حسين
زيرو
zero
أضرب
how to do it as a zero
اضرب في نيجاتيف 2
I will multiply the first row in negative 2 and I will add it on 2 multiply negative 2 plus 2
يا عم والله ما فيش
محدش بيرد عليا
زيرو
0 negative 2 times negative 1 ب 2 plus 1
3
negative 2 times negative 2 is gonna be
نيجاتيف 4
4 plus 1 is gonna be this element is not gonna change 0 3 and 4 this is what I want
ليه عمل اللفه دي كلها؟
موسم تزاوج
اقدر اعمل 500 حركه
موسم تزاوج
دي مش الايديال بس دي اللي جت في دماغي وبرضه ما عملتش violation for the main rules okay is this an upper triangular matrix
لازم اضرب بقى في
اوكي
في 3
اوكي هضرب مين اللي في 3
لا احنا لسه عايزين نجيب
معلش ايه اديله هو بس ايه فرصه قول لي بقى انت بتقول لي 3 فكر قبل ما تتكلم
ماشي
هضرب مين في 3
اخر رو تحت
اخر الرو تحت اضربه في 3
لا
انا معاك
لا اضرب فوق يعني لو الرول اللي في النص
الرو اللي في النص والرو اللي فوق
في النص
اللي في اضرب 3 times 0
زيرو
plus 0 is gonna be 0
زيرو
3 times 3
6 9
9 plus 3 is 12
احنا عايزين نخليها 1 اصلا
بس انت عايز 3 شغله 1
نيجاتيف
هضربها في واحد
انا عايز اخلي ده
هضربها في
بزيرو
3
هضربها في
هضربها في 3
نيجاتيف 1 واقدر
صح I can multiply the second row in negative 1 and add it on the
ماشي
third row انا اقدر اعمل كل حاجه okay I will use it okay I will leave the first row as it is طبعا of course negative 1 times negative 1 is positive خلاص so it's gonna be a 1 I'm not gonna change it negative 1 negative 2 then the second row I'm not gonna play with it it's 0 3 and what's going to change the third row so I will multiply negative 3 and add I'm sorry negative 1 negative 1 times 0 plus 0 Negative 3 plus 3, it's gonna be
0
0. Negative 5 plus 4, it's gonna be. So the result will be of this matrix, it's gonna be, of this determinant, it's gonna be negative 3, direct. Okay? It's not the only solution, Mr. Hussein. I can play with it as I want. But just to only keep the properties in your mind. Let's see how he did it. Okay, step by step. First thing, okay, he interchanged the rows. Okay? So the sign changed. Then he multiplied. Once you do this, then he multiplied the first row in positive 2 and added on the second row. That's the second row. Then for the third one, he multiplied by a negative and add on the last row. So once you multiply in a negative and adding, this is the result that you will have. Start multiplying. Negative 1 times 3 times negative 1 is positive 3. Don't forget the sign outside, which is gonna be. It's exactly the same.
بس الطريقة دي
Whatever.
بس أنا صعب والله
مش طريقة.
Science.
بص زيادة، هي مش طريقة.
اه
هي you are using الطريقة إنك to use the row operations.
ماشي.
But arrange them up to your mind. But don't violate the rules.
هو أنا هاخد درجات على الوركينج اوت ده صح؟
دي أسئلة تريفيال دلوقتي. أكيد لما تمشي ستابس هتاخد درجات. بس دي أسئلة تريفيال دلوقتي. المهم دلوقتي إنك to master how to play with them. Okay? Let's do it once more.
وانا بلعب بيهم على اساس يعني انهي رقم هيساعدني ان انا اوصل
للبرنسبل diagram. It's up to you.
لو تاني رو مثلا هو اول كولم 1 اروح مبدل انا تاني رو باول رو.
اعمل اللي انت عايزه. تعال بص كده ده واحد تاني اهو.
هو زي الفل ده.
ماشي. عشان بس هو الاولاني مظبوط، بس هو مش دايما الاولاني يبقى مظبوط.
ما انا بقول.
اوكي؟ طبعا هنا اسهل حاجه تعملها دايما، يعني لو انت مش عايز تتلخبط قوي، حاول تو افويد انك تضرب في نمبر او تاخد كومن او تسويتش روز. هنا الارقام خد بالك. I can simply يعني لو انا عايز ايديز، حد يديني الايديز.
هضرب كل اللي فوق بنيجاتيف 2
وادد على اللاست رو. انا فعلا لو عملت مالتيبليكيشن، شوف سلمى خدت بالها من حاله لسه واخد بالي حاله منها. لو ضربت الفيرست رو النيجاتيف 2 وادد على اللاست رو هيديني كومبليت رو بزيروز. انت عارف ان اي determinant with a complete row in zeros the value of this determinant will be zero. في ثانيه ضربت النيجاتيف 2 وادد خلاص you have to evaluate. It's equal.
حلو.
تمام؟ هنا النمبرز خدمتك for this special case. اوكي؟ طيب تعال بص على ده 4 by 4. لو انت بتحسبه بالطرق العاديه it's not gonna be easy. but هنا بقى let's يعني let's come to a common thing. If I want to evaluate this determinant يا زياد لو انا عايز احسب الديترمنت ده انا ممكن مش اعمله بالطريقه دي. I don't have to. I can use Sarah's rule. صح يا زياد؟
صح.
لا انت سبتني تلعب في الموبايل.
والله لسه ماسك حاجه.
ما تمسكوش اصلا. I can evaluate the value of this determinant using Sarah's rule. ازاي تعمل Sarah's rule؟
اضرب
1 3 4
في
الراس.
الراس
2 times negative 1 times negative 2 plus 1 times 0 times 1 minus do it
الناحيه
in the reverse direction. It's done. اوكي؟ بس وده يمشي نفس الكلام لانه 3 by 3.
كله يمشي ثلاث رول
حلو
الا 4 ده.
وريني.
لا
مش
مش
هتعرف.
هضرب انا.
طيب مش هينفع اصلا.
في كام
بس
قاعدة؟
مين اللي ينفع؟
لا والله ممكن ثلاث
جاست ما ينفعش يا بابا.
ليه طيب؟
ما ينفعش لان الترتيب بتاع الثلاث رول جاست اونلي فور 3 by 3.
ما ينفعش.
الترتيبه اللي انت شغال عليها.
ما ينفعش اضرب
جاست
1 في نيجاتيف 3 في 2.
لا ما ينفعش مش فاتح مش
ماشي.
هتفرق. طيب ايه اللي ينفع؟ ينفع استخدم لابلاس الكوفاكتور ميثود. لو انا استخدمت لابلاس يبقى انا I will expand this determinant into 4 determinants each one of them is 3 by 3. طيب خلاص انا مش عايز اعمل كده. الطريقه دي تمتنج في الوقت الراهن. لو سمحت الكل بلا استثناء بص لي على ده وقول لي اعمل فيه ايه عشان اعرف اشتغل.
ابدل اول رو تاني رو.
ماشي حلو. لو انا بدلت كده يبقى في هنا ايه بره؟ نيجاتيف ساين.
ماشي
صح؟ دي واحده. في افكار ثانيه؟
ليه
لا،
بفرق الساين؟
معلش اديني افكار ثانيه.
ليه نيجاتيف ساين؟
لانك عملت سويتش للروز.
اوه
احنا ممكن نعمل لاست رو
الله
ها؟
مالتبلاي 2 في اول رو.
لو انا ملتبلاي ده في 2 في اول رو هيخليني 0، انا مش عايز 0.
عايز 1
1
هخليها طلع
وخلاص.
هعمل لهم
Multiply
شيفت
one
وملتبلاي باي نيجاتيف 1 مش ده
طب
تبقى 1
انا ليه اعمل شيفت اصلا؟
ماشي مع
طب ما I can add
بالظبط.
I can add the last row to the first row. في الحالة دي مش هحط أي نمبرز بره. مش أنت فاكر ال 3 اوبريشنز؟ خلي بالك هنا مفيش ideal solution بس في multiple options. Don't violate the rules. يبقى أنا لو مكانك أول حركة تنفع تبقى 500,000 حاجة في الديترمنت.
يعني لو عملت
يعني رقم واحد بس اسمعني رقم واحد I can switch the rows. لو انا عملت switch the rows اول ما اعملهم لازم احط هنا نيجاتيف ساين. يبقى دي واحده. ممكن ما اعملش كده. ممكن يبقى انا دماغي ستك في اللاست رو هاخد نيجاتيف ساين at a common بعدين I will switch them. then هيديني نيجاتيف then نيجاتيف تاني يقلب بوزيتيف. ممكن حاجه ثانيه I will multiply the second row in negative 1 وadd it on the first row. ينفع هيخلي لي ده بوزيتيف 1. انت معايا يا نور؟ I can add the last row on the first row. If I were in your shoe انا داخليا يعني جاي كلهم زي بعض but I would prefer to add عشان not to put numbers or signs outside this determinant. تعال نحلها مع بعض تاني. زي ما قلت لك ينفع 500 حاجه اللي انا بعمله مش الايديال. It's not the only solution. It's not the ideal solution. But just hit my mind. I will add the last row on the first row. حد يمليني.
Last row the first row.
Negative 1 plus 2
1
1. Negative 1 plus 0 negative 1. 0 plus negative 2 negative 2. 2 plus 2 خلاص it's done. I don't have to change the value of the determinant. مش لازم اغير the sign.
وبعدين ابدا بقى
بعدين هبدا اكمل. I need 0 beneath this positive one. How to do it?
ليه؟
ها؟
اه
قول.
هي اللي احنا نضربها في نيجاتيف دي بروبرتي يعني.
يا نهار ابيض.
انا ما ضربتش.
لا لما اجي
يعني
اغير
هتبقى 1 و0 ونيجاتيف 1
تاني.
و0
بقى معلش عشان بس اجاوب واحد وارجوك اسمع زميلك.
لما نسويتش الرو
لو سويتش درو لازم اضرب في نيجاتيف.
ليه؟
يعني دي من الرولز.